So today I will start the fourth module, that is your linear programming. Linear programming, from the word linear, it's a linear. It will show the linear relationship between variables. So it is also known as linear optimization. Now the question comes: what is optimization? Optimization means you should get the best input. Best input you should choose to get the best output in the sense, let's say we want to maximize the profit. The profit should always be maximized, so there should be the input level. Suppose there are two or three variables, x y and x1 x2 x3. These influences your total profit. So what will be the best values of your variables x1 x2 and x3, that will give the maximum profit. That you have to determine the values of x1 x2 x3. I'm giving you one example. This is x1 x2 x3, maybe more than that. So and all these variables have linear relationships among themselves. So that is your linear optimization. Linear programming we used to do for determining the optimization, to getting the best values of all the input parameters. So we represent in terms of a mathematical model. Mathematical model means in terms of equations. Mathematical equations. We determine the relationship in the form of mathematical model in terms of equations. So this is your and linear programming problem is abbreviated as LPP. And so before that, what are the requirements of a LPP or a linear programming problem? It should have a well defined objective function. Suppose we want to determine the profit, maximizing profit or minimizing cost. Profit should be maximized and cost should be always minimized. So we always use the objective function either for maximization or for minimization. So let's say it's an objective function for maximizing the profit. So your objective function is the profit. Profit should be should be represented in relationship with your different variables, which is associated with determining the profit. That is the objective function. And it can be expressed as a linear function of decision variable. That x1 x2 x3 that I was telling you, that were known as decision variables, because these x1 x2 and x3 used to decide the profit condition. So that's why these are known as your decision variables. And next is that, and then among this decision variable there should be relationship, and decision variables should be interrelated and should be non-negative. So now I'll give you one example. First of all, this is one question given to you. First, you will in the question is given to you. You have to, unless and until you put it in a format in a mathematical equation, you cannot solve it. That means you cannot determine the optimal values. So first you should read the question, and you should try to formulate the mathematical problem. So and after that, next step is your computation, that is your optimization. So in this question you can see that there are three different machines, m1 m2 and m3, and there are three products that are produced for product 1, product 2 and product 3. As I've already taught you in sequencing, that product 1 one will be processed, that different machines used to be processed, that means the product used to go through different machines for their processing. So product 1 requires machine 1, and it should be processed for at least 2 minutes. Time is in unit, it is given 2 minutes. Then it will go to m2 for 4 minutes. Then for m3 it will be going for 2 minutes. Likewise, these are the timings of your other machines. So, and what is the machine capacity? What is the capacity of machine 1? Machine 1 can maximum work out for 440 minutes per day. Maybe process for product 1, product 2 and including all product 1, product 2 and product 3, maximum capacity is 440 minutes per day, and machine 2 can work out for 470 minutes per day. Similarly, machine 3 can work out for 430 minutes per day. So this is the question given to you, and you have to determine it is required to determine the daily number of units to be manufactured for each product. You have to determine how many total that means the suppose products 1 2, we don't know till now, we don't know how many quantities of products are one. You have seen the three products, one, two, three products. How many quantities of product one are produced? How many quantities of product two are produced? How many quantities of product three are produced? We don't know. We have to determine that. Suppose let's say the quantities of the product one manufactured be x1, number of products manufactured of product two will be x2 and x. So we have to assume like our in our linear equation. Not assume, we have to let's say assume. Okay, then profit per unit is given that for product one, profit will be rupees per unit. For one amount it will rupees 4, and if you are having producing x1 amount means it will be your profit will be 4x1, isn't it? Normal mathematics. And profit for of product 2 is rupees 3 per unit, and number of if you assume that number of units produced of product 2 is x2 means your total profit will be 3x2. Similarly, profit per unit for product 3 is rupees 6 per unit. This is the profit. And what is the quantity produced? It is x3. So total profit of product 3 will be 6x3. So likewise, so this is the question. So you have to formulate the linear programming problem that will maximize the daily profit. So it is a problem of maximization. So before that, first, the very first, if I am writing the solution, let the quantity of products let the quantity of products 1 2 3 manufactured, as I have told you, we have to assume that like in linear equation we used to solve daily be x1 x1 x2 and x3 units. And here you obviously here x1 x2 and x3 all are greater than equal to 0. So now the first step is you have to determine the objective function. I think I've already told you that first you have to define the objective function. Objective function is our maximization. We have to maximize the profit. So let's say that objective function name always we used to give Z. Maximize, it should be written maximize because this is a problem of maximization. Only Z if you write, that's not correct. And if some problem would have been that for minimize the cost, then you would have written minimize Z. As this is the problem of maximization, so I am writing down maximize Z. Okay, what is then what yeah, that means profit. I've already told you that the total profit of product 1 will be 4x1, for product 2 will be 3x1, and for product 3 will be 3x2, and for product 3 will be 6x3. This will be the total profit. This Z is the gross profit. Okay, so it will be total profit or Z is equal to 4x1 plus 3x2. This is the 4 and 4, 3 and 6 are the profit of individual products per unit. So number of units I have multiplied, this is the max, this is the profit. But till now we don't know what is the number quantities of x1 x2 and x3, that we have to determine it. So this is the objective function. Okay, for your understanding, this is the objective function we have already determined. Next, relationship between decision variables. What are the decision variables? Decision variables are your x1 x2 and x3. X1, X2 and X3 are your decision variables. Okay. Now these are then we have to determine the relationship. Now we'll go to the table. What is given? Then product 1 will be manufactured. Product 1 will be processed on machine 1 for 2 minutes. Then maximum capacity of machine 1 is 440. So it will be 2 into number of quantities of product 1. Number of quantities are x1. Then number of quantities of product 2 is uh, 3 minutes is processed for one product, one part of product 2. So x2 number will be, time will be 3x2. So 2x1 plus 3x2 plus 2x3 will is the total time of time that is being worked on machine 1. And what is the limitation? It should not exceed 440. That means it should be less than, either it is equal to or it should be less than 440, because the maximum capacity of machine M1 is 440 minutes per day. So, so now the constraint, this maximize Z, we used to write down what is the limitation. Constraint means limitation, subjected to constraints. What is first constant? It is 2x1 plus 3x2, 2x1 plus 3x2. See the table, and then 2x1 plus 3x2 plus 2x3 less than equal to 440, plus 2x3 less than equal to 440. That means for machine when one will work for 2x1 for part 1 product 1, 3x2 time minutes for product 2, and 2x3 for product 3. Similarly, for machine 2, limitation is less than equal to 470. Likewise, for here nothing is there means that is 0. That's why it is dash. That means machine 2 only product 1 and product 3 are being processed. And so here it will be, your x variable will be, x2 variable will be 0. So it is 4x1 plus 0. But I am writing it down. I am not avoiding this, because when you will be working out the problem, then you will be needing it this 0 term, because you have to fit the value 0 coefficient of x2 in the second case. Similarly, machine 3 limitation is 430 minutes per day. It is 2x1 plus 5x2 plus 0x3. 2x1 plus 5x2 plus 0x3 is less than equal to 430. So this is the mathematical formulations we have done. For working out linear optimization or linear programming problem, we need only these things. One is the objective function, and others are the constant equations or inequations. You can see, if these things are given to you, you can easily work out the linear programming problem and find out the optimal values of your x1, x2 and x3. So in the next class or tomorrow, I will teach you how to work out this problem by linear optimization. So now you have learned how to formulate the problem. This is if your formulation is right, means you can work out you can get the right solution. So you should know the formulation of problem also. You can see I have read the question along with you, and I have formulated the objective function and the constant equations, inequations, you can rather say. So next method is the graphical method. Graphical method. Graphical method. Then LPP. Then when you will use graphical method, mathematical method is there, also graphical method is there. Graphical method is the very simpler one. When LPP involves only two decision variables. In the previous example I showed you, there were three decision variables, x1, x2 and x3. In this condition you cannot apply graphical method. You can apply graphical method only when it involves two decision variables. Two decision variables only. If it is more, if you get more than two decision variables, means that time you cannot use this graphical method. So it is very simple. Now I am writing down one problem and I'll solve by graphical method. Question is, find the maximum value of z. Z, you know, z is a capital Z is a symbol for objective function. Find the maximum value of z, and it is given that z is equal to 5x1 plus 7x2. such that x1 plus x2 is less than equal to 4 and 3x1 plus 8x2 is less than equal to 24, 10x1 plus 7x2 is less than equal to 35, where x1 and x2 greater than 0. This is the question given to you, and you have to solve by graphical method because it involves only two variables, two decision variable, that is they are x1 and x2. How to solve it? So first step is that number 1, replace all the inequalities. You can see 1, 2, 3, all the inequalities by equations. Replace all the inequalities of the constraint forming equations. Now you will make equations. Equations always involve your equal to sign. So that's why now it will be x1 plus x2 is equal to 4. 3x1 plus 8x2 is equal to 24. 10x1 plus 7x2 is equal to 35. Let me write down. X1 plus x2 is equal to 4. 3x1 plus 8x2 is equal to 24. 10x1 plus 7x2 is equal to 35. So next what we will do, we will consider one equation. Okay. If first equation, if x1 is 0, if x1 is 0, if x1 is equal to 0, what will be x2? X2 will be 4. X2 is equal to 4. Similarly, conversely, if we take x2 0, x1 will be 4. So, thus we can, if x2 is equal to 0, then x1 is equal to 4 for the first equation. Let's say this is equation 1, equation 2, this is equation 3. Thus we can say that x1 plus x2 is equal to 4 passes through, we'll make the coordinates, passes through first if x1 is 0, 0, 4 and 4, 0, 4, 0, 4, 0. Okay, so we have to plot this in xy coordinate. Similarly, we have to compute the x1 and x2 values for equation 2 and equation 3. Similarly, if we put x1 0 in case of equation 2, what we will get x2? We will get 3. Similarly, if we put x2 is equal to 0, we will get x1 is equal to 8. So thus, equation 3x1 plus 8x2 is equal to 24 passes through points 0, 3 and 8, 0. Similarly, for third equation, you can do 10x1 plus 7x2 is equal to 35. It passes through point 0.05 and 3.50. So in all the cases, we are putting either both the variables 0, 0 at a time, then not at a time, one by one, then we are determining the value of other. And now the next step is that we have to plot these values. So we'll draw xy axis and ordinate. From x axis we need up to 8 we need it, you can see, and y we need up to 5. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Next it is 1, 2, 3, 4, 5. Let's say it is 6. Here let's say we have done up to 9. Now we'll start plotting. Equation 1. Equation 1 coordinates are 0, 4 and 4, 0. So it is your 0, 4, this point, and 4, 0. So this point, we have to join this. So this is equation 1. Equation 1. This line belongs to equation 1. Next is your 0, 3 and 8, 0. 0, 3 and 8, 0. So we have to join this two. Mine is not straight, but you can understand. Okay. So 3, 8, this is equation. This is equation 2. Then third one is your 0, 5, 0, 5 and 3.50. Okay. 0, 5. 0, 5 and 3.50. 3.5. That means here 3.50. That means you have to join these two. So here if you do it, let's say here. Okay, you got it this much. So now you can see that this is equation 3. Now if you give the naming, the first one, let's say this point was AB, this is A, this point it is B, then second graph this is C, this is this point D, and this is, let's say this is E, and this is F. So I have plotted it F. Okay. Now how can we have to determine x1 and x2. Before that, area that is a common area. That means the common area is the region which will give you the values of your x1 and x2. That means any point that falls on this line or in the area below the line. You can see that this is the common region. Common region, I am just shading it. This is the common region for all the three equations. You can see that. And here two points are there. I am giving as this point as G and this point as H. H. These are the common points. And how can we determine it? Any point that falls. This is in this equation. This is a problem for maximization. Maximization problem. Maximization problem. Another thing that I will be telling in the later classes also. But still, then you note down the symbol of the all constants should be less than equal to. Less than equal to. So mark the region. So in all this problem is your less than equal to. So if it is less than equal to, then mark the region. That means mark the region, common region, that is a common region below the line, below the line. And below the line, and if greater than equal to above the line. So in this problem, all the constants are less than equal to. Less than equal to means below the line. Below the line, common area is here this much. That means O, C, G, H, and F. G, H, and F, not B. This is the common region F, and the coordinates for F is, so this point we need. This is the common region. So this is the common region, common, that these points, coordinates of these points we needed. So coordinate of C is our 0, 3. Coordinate of C is 0, 3. Then coordinate of your F is your 3.5. F is equal to 3.50. Then we don't know the coordinates of G and H. That we need to determine it. So how to determine it? We can see that point G is the intersection of, for how point G we got it. Point G is the intersection of equation 2 and equation 1. Point G, intersection of lines. What is equation 2, equation 1 and equation 2? G, you can see this is 2 and that means 1 and 2, equation 1 and 2. That means your uh, x1 plus x2 is equal to 4, and 3x1 plus 8x2 is equal to 24. So x1 plus x2 is equal to 4, and 3x1 plus 8x2 is equal to 24. So in this way, I think it's very easy. So you can, these are the two linear equations having the two variables. You can easily solve it, and if you solve it by normal mathematics, you will get the values of your x1 and x2. So then you will get the values of your x1 and x2 for point G. That means for these are the values for your x1 and x2 are the coordinates of point G. Rather, you can write down coordinates of G, and this will be your x1 and x2. And here coordinate, if you solve it, you will get 1.6 and 2.4. So G coordinate, you have got it 1.6, 1.6 and 2.4. Next is your point H. Point H, you can see point H is the intersection of line equation 1 and equation 3. Intersection of lines equation 1 and equation 3, that is your 10x1 plus 7x2 is equal to 35. If you solve it, you will get the coordinates of H is equal to 2.4, 1.6. Now you got the coordinates of all the points. That is your C, F, C, G, H, and F. So a common area belonging to the common area. So here you should not get confused between this line. So I am drawing the very close hatched lines. So now you're getting so many x1, x2 values. First for C you got the x1, x2 value 0 and 3. For F point you got the x1, x2 value 3.50. For G you got the x1, x2 values 1.6 and 2.4. And for H also you got the x1 and x2 values 2.4, 1.6. How to know which one is the optimum out of these four? We have to determine the optimum value of best value of all these four that will maximize the profit. The main question is maximizing profit. We have to put the values of all these four coordinate points in this equation, and which will give the maximum value of z. That will be the optimum values of your x1 and x2. So we will put in z as z is the maximization of profit is equal to 5x1 plus 7x2. So I'm just writing down, putting the values of x1 and x2 of points f, h, g and c in objective function z. So if you put for f is equal to 3.50, first case, that means for f is equal, for a point f you will get z is equal to 17.5. Similarly, if you put for h, coordinates for h is your 2.4 and 1.6, you will get the z is equal to 23.2. Similarly, for g, you will get 1.6 and 2.4. So z is equal to 24.8, you will get it. For c, you will get 0.3. 0.3 for C03 you will get Z is equal to 21. So it is very clear that for for G is equal to 1.6 and 2.4, your Z value is maximum 24.8. This is the problem for maximization the profit. So that's why the optimal solution of the optimum values of the optimal values of x1 and x2 are 1.6 and 2.4. See how simple it was for solving by graphical method if it involves two variables. But in the next class, I'll work out if it involves more than two variables. The process is easy, but it is very lengthy process to get the optimal solution of x1, x2, and x3. So you practice more and more problems regarding this. Okay.